Here we've got y between two constants and then x between two functions of y, and the problem is asking us to rewrite this so that we have inequalities where x is between two constants. That would mean y is probably going to have to be between two functions of x. Let's just start off by sketching the region. Y is between 0 and 8. That means, let's see, y equals 8 is this horizontal line here, and y equals 0 is this horizontal line here, on the x-axis. And so saying y is between 0 and 8 is just saying you're somewhere in this horizontal band. And then x is between y over 4 and y to the 1/3. Now to graph these, think about when x is on this extreme side, right? Then x is equal to y over 4. It might be easier if we just write that as y equals 4x. It's a more familiar form for us. This is a line through the origin with slope 4. So for every 1 you go over, you go up 4. That puts a point here. And then go over another 1 and up 4. And we can see we're going to be at that intersection point there on the, so draw in this line here. The other inequality, the other end of the inequality, is when x is equal to y to the 1/3. Again, it'd be easier for us to graph this if we wrote it in the more familiar form. Y is equal to x cubed. So that goes through the point 0, 0, and it goes through the point 1 cubed is 1, so it goes through the point 1, 1, and 2 cubed is 8, so it goes through that point. So our curve is going to look something like this. Okay, so the region described by these two inequalities then is this region in here. Right? For every y value between 0 and 8, the x value starts at this line and increases until it hits this curve y to the 1/3. Now what we want to do is to rewrite it so that we have x between two constants. So we want to put it between two vertical lines, and we can see it would go between the vertical line x equals 0 and the vertical line x equals 2. So x is going to be between 0 and 2. And then for any point between 0 and 2, the y value is going to start out on the cubic function and go until it hits the line. So the equation of the cubic function is y equals x cubed, so that's going to be our lower bound. And the equation of the line was y equals 4x, so that's going to be our upper bound. So we've taken this region, this set of inequalities, and rewritten them as a different set of inequalities, this time with x between two constants. Here we've got the region, y is again between two constants, and x is between two functions of y, although it's a fairly simple function of y. And we want to rewrite it using inequalities with x between two constants instead of y. So let's start by sketching this. Let's see, the square root of 3 is about 1.7. So we've got a horizontal line here, about like that, right? And then the line y equals 0, that's the other end of the bounds on y, is this horizontal line. The line x equals 0 is the y-axis, and the line x equals the arctan of y. Now we know that x is going to be an angle between minus pi halves and pi halves. We would recognize this better if we wrote it this way, that the tangent of x is y. So if y is the tangent of x, let's see, the tangent of, if x is 0, the tangent of 0 is 0. And the tangent of pi halves is, let's see, the tangent of pi halves is, is undefined. Okay, so there's a vertical asymptote in tangent here. And let's see, what other points do we know? Let's see, pi 6, the tangent of pi 6 is 1 over root 3, so let's see, pi 6 would be around here about 0.16 pi. So 1 over 1.7 is going to be a little bit more than a half. Okay, and the tangent of pi thirds. Oh, that would be, pi thirds would be right here. The tangent of pi thirds is root 3, so our curves intersect there. So we've got our tangent curve coming through. Oops, let me be a little bit more bowed. There's our y equals the tangent of x. Okay, so we're saying for any y value between these two, the x value starts at 0 and increases until it hits the arctan. So we've got this region here, and we want to describe it this time with x between two constants. So if we try to put this region between two vertical lines, we get the line x equals 0, and then where these intersected, that was at pi thirds, since the tangent of pi thirds was root 3. So x is going to go between 0 and pi thirds, and then for every x value in here, y is going to start out on the tangent curve and go until it reaches this value of constant y. So the y value is always going to be less than or equal to the square root of 3, but it's going to start at this curve, which in terms of x is tan x. So we have now our region written. It was given to us with y between two constants, and we've just drawn the sketch, and we're able to convert it so that it's a region with x between two constants and y between two functions of x. There's another region. I'm going to sketch the region described by y between two constants. Okay, so y equals 0 is the x-axis, and the other end of this inequality is that y equals 1. So that first inequality just says that that all the points have to be somewhere in this band, this horizontal band, because the y values are always between 0 and 1. And this next one says x has to be between 0 and e to the y. So x equals 0, that's on the one extreme end, would be this vertical line here. And x equal root y, let's see, if x equal e to the y, sorry, if x is e to the y, that means the natural log of x is y. So that's a more familiar form. Let's see. So the natural log of 1 is 0, and the natural log of e is 1. E is about 2.7-ish, so there's a point there. So we know the graph of the natural log is going to do something like this with a vertical asymptote at 0. But the region we have has to be within this band, this horizontal band, because y is between 0 and 1, and the x values are all here between 0 and when they hit this curve, which is e to the y, or ln x. Okay, how could we describe this region by putting x between two constants? If I try to do it, something kind of, that's at e, right? So I know x has got to be less than e. When x is between 1 and e, then the y values start on this natural log curve and go until they reach this constant. When you're over here less than 1, the y values just start at 0 and go to 1. So this region is a little bit harder to put between two constant bounds of x because its character changes a little bit when you cross over 1. We could do two sets of inequalities to do this. We could say, okay, as long as the x value is between 0 and 1, then the y value climbs from 0 and ends at 1. So the y value is between 0 and 1. That just specifies that square region right here. Okay, and the next region would be when x is between 1 and e. Over here, when x is between 1 and e, the y value climbs from this curve, which in terms of x is ln x, until it reaches 1. So y goes from ln x up to 1. So in this case, it's a little more compact to write the region. It fits nicer between two horizontal lines. You can use just one pair of inequalities to describe it. This one is a little bit trickier, so you put it between two vertical lines, and now you have to use two sets of inequalities, right? So you have to have either x and y in this range or x and y in that range. Together, those two sets of inequalities, two sets of two inequalities each describe the region.